Statistic values of an invertible n by n matrices A are lambda 1 up to lambda n, and no eigenvalues of lambda I is 0 because of these are the eigenvalues of invertible matrices. Then the characteristic values of adjoint A. To find eigenvalues of adjoint A, first we recall a result. Determinant of adjoint up to adjoint A, and adjoint is appear k times, then this value is equals to determinant of A raised to the power n minus 1 raised to the power k. N is the size of the matrix and the k is the how many times this adjoint is appear. In this case we have to find adjoint A. So adjoint A will equals to determinant of A raised to the power n minus 1, and eigenvalues of A are lambda 1 lambda 2 up to lambda n, so their product will be determinant. So lambda 1 lambda n raised to the power n, and you can sorry n minus 1, and it can be written as lambda 1 n minus 1 up to lambda n n minus 1. So call it this is the equation 1, and options are given for eigenvalues of adjoint. So we verify which eigenvalues giving the determinant of adjoint. So first option is option A is saying 1 upon lambda r, and values of r is up to n. So its a determinant. So product of eigenvalue will be 1 upon lambda 1, lambda 2, and so on, lambda n, and this one is equals to determinant of A, not equal to determinant of A raised to the power n. So option A is not true. Now come to the option B. Option B is 1 upon option B 1 upon lambda r A. So lambda 1 determinant A. This is determinant A. So lambda 1 determinant A into 1 upon lambda 2 determinant A into lambda 3 determinant A, and so on 1 upon lambda n determinant of A, and this one can be written as 1 upon lambda 1 lambda 2 up to lambda n, and determinant of A raised to the power n. This one is also not equals to determinant of A raised to the power n. So option B is not true. Now come to the option C. Option C is determinant A upon lambda r, determinant of A lambda r. So lambda 1 into determinant of A lambda 2, and so on determinant of A lambda n. In denominator I can write product of lambda IR as determinant of A, and in numerator determinant of A raised to the power n. So this one cancel out n minus 1 times. So determinant of A n minus 1. So this is equivalent to this equation. As you can see, determinant of adjoint A equals to determinant of A raised to the power n minus 1. So option C will be correct. But you can verify option D also, and this problem can be approached in different way as A inverse equals to adjoint A upon determinant of A, and this one can be written as determinant A inverse equals to adjoint A. So eigenvalues of adjoint A will same as determinant of A, because of determinant will be the value or some constant upon lambda r type. Because of eigenvalues of A inverse is as 1 upon lambda 1, 1 upon lambda 2, and so on 1 upon lambda r or n. Using this eigenvalues of adjoint A will be determinant of A upon lambda r, and using this one we can directly tick option C.